All right, it's day 10 of Advent of Code. Well, actually, it's day 11. I was a little bit late in publishing this video. Sorry about that, but try to get back on track. And it's also raining because it's December in California. So sorry if there's a little bit of noise from that dripping. I'm going to try to talk loud enough to speak over it, so hopefully it's not too distracting. But for this day 10 problem, we are dealing with we're reading in instructions for a machine, like very simple machine code. Basically, there are only two types of commands that we might read. We have this add command and we have no-op. And the add command, it adjusts there's one register in our machine, and the add value just changes what's in that register. So in some sense, this is a little bit straightforward because all we're doing is tracking what's going on in the register. The one thing that complicates it a little bit is that we're tracking different cycles, like machine cycles, and the add operation takes 2 cycles, the no-op takes only 1, so that adds a little bit of a wrinkle. But in this first part, basically periodically, so at cycle 20, 60, 100, 140, 180, 220, we are going to take the register value and we're going to multiply it by the cycle number. We're going to add all of those up to get our total signal strength. That's the final answer we're looking for in part 1. Then in part 2, we're doing something a little more complicated, where we are trying to render a string that is basically, it goes through this whole process for how these commands actually render that string. So we can see that the screen is basically 40 wide by 6 tall in terms of pixels, and there are all these rules for whether a pixel is light, which is to say uses the pound sign, the hashtag, or whether it's dark, whether it uses a period. So effectively, we'll go through those rules as we go through that function. Basically, whatever the register value is, it'll oscillate between 0 and 40, and as long as the cycle number, like mod 40, is within the range, then it'll be light. Is within the range of like that value plus or minus 1, then it's a light pixel. Otherwise, it's a dark pixel. So that's what happens. At the end, we'll actually get a message if we've done it right. So that's pretty cool. But anyways, let's jump into the solution here. So, all right, parsing it. We've just got our instructions. We're just going line by line instructions. There's nothing hard here. We have the no-op parser. So either it's just a string and we return no-op, or we just take string at x and then parse a signed integer. So that's something that's a little different from most of our previous problems. So this is that they were always positive integers. Now we have to, it can be either plus or minus. I guess I'll open up the utils just so we can see what that looks like. So we can either parse a positive number or we can parse a negative number. And how do we parse a negative number? Well, first we take the character negative, and then we parse a positive number, and we multiply the result by -1. So nothing too complicated with parsing this. Where it gets a little more tricky is that we want to, we're folding through the instructions and we're keeping track of our machine's state. So the important elements of the state obviously are the cycle number, because we need to know how many cycles we run, because that's important for the signal strength. I think it's also important in the rendering process as well. I keep talking about this register value that gets updated with each add operation. And then we basically have fields for our accumulated answers. So the accumulated signal strength refers to the first part of the problem, and then the rendered string refers to the second part of the problem. So we'll see how those update with each instruction that we pass. And I did manage to write this solution so that it works well, the same code. And I did manage to write this solution so that the same code basically works for part 1 and part 2 all at once. So there's only a few parts of this really. So the first thing we really want to account for is just, okay, we want one function that's just going to basically bump the cycle. It's going to do nothing else except process one cycle regardless of what the command is. So this isn't going to handle our addition. All this does is we increase the cycle number, and we just take whatever our input register value is, that's our output register value for this particular function. but then we have to accumulate the values that we get for the different parts of the problem. And so what does that mean? So in part 1, we have to look at the cycle number. And if it's, there is this hard-coded set of signal cycles that we are interested in. And so if it's a member of that, the cycle number, then we take our register value, current register value, we multiply by the cycle number, and ultimately we're going to add this to the previously accumulated value. This is where the magic really happens for getting that first solution. And then for the second part, so this is where our logic is really going to happen for rendering our string. We're either doing this light bit with the hashtag, or we're doing the dark bit with a period, and we're just appending that new character to the render. This is all the logic that really goes into determining that. We take the current register value and that -1, +1, and we compare it with this value. This value, we take mod 40 because we're that basically says, okay, where along I guess the vertical axis are we? So where along here are we doing? But we also have to subtract 1, because on cycle 1 we're going to end up with 0 mod 40. So we have to subtract 1 from the cycle number, and then we take mod 40, and that'll get our position along here. And so if that position is either equal to the current register value or plus -1, then we get a light bit. So this is really the core logic of the algorithm. There's one, we have to put a layer on top of that as we process the different instructions. So with a no-op, all we do is bump the cycle. Nothing else changes. And we have one cycle, we run the cycle, and then we just take our original machine state, we get a new machine state. With adding a number, because adding takes 2 cycles, we bump the cycle twice. So we take our original machine state, bump the cycle. Take the new machine state, ms1, bump it again, and only after that is complete, then we reset the register value by adding the value that was in the instruction. So not too difficult once you've sort of put it all together in your head and worked out how these pieces fit together. After that, everything else is really easy. The initial machine state, as the problem specifies, our cycle number initially is 1, our register value is initially 1, and we start with these empty inputs. And then for the first part, we fold through all of the instructions. Remember, I have managed to write most of my solutions for Advent of Code in this kind of folding pattern, where we take A and B and return an A. And so we fold through the instructions, and just for part 1, we want the accumulated signal strength. For part 2, all that changes is we just want the rendered string, and we also want to reverse the rendered string, because notice how we're appending in the front every time. So that will basically give us what we want. And the last sort of thing you'll need to do is use code something like this on the hard part, because you take chunks of 40 in order to divide it into the different lines of that string, and you'll need to log it somehow. And you will get a string that actually shows you a sequence of letters if you've done this right, and then you'll have your answer. So I can actually go into my test code at the very bottom here. This is sort of the first sample solution that I copied from the problem description, and this is the solution for my code. It's a little hard to make out, but we can see we've got a P in these first few columns, then we've got a B, Z, G, R, I think this is A, Z, and another A. So really cool how they pulled that off. But this is, these are the signal strength values I get. So that's day 10, and nothing else to it really. I guess I can just run my tests, make sure they're still passing. But as you can see, I've already completed day 11, so filming this video a little late. But yeah, that's pretty much all the code we need for day 10. So hopefully you are keeping up well with Advent of Code. I'll be, back with another video very soon, and I'll be, continuing to solve problems throughout this week. So hope you're enjoying this. Make sure to subscribe to the YouTube channel and to our mailing list using the link in the video description. Have a nice day.